Today, we uncover the mystery behind a canned meat icon known worldwide. You've probably seen it on shelves, a blue and yellow tin with bold letters, SPAM. But what really goes into this curious can of meat? How is it made? Why does it last so long without refrigeration? And what happens inside a Spam factory that allows it to produce millions of cans each year? Let's open the lid on this factory process and witness one of the most automated meat production lines in the world. Welcome to the world of canned meat. Welcome to the Spam factory. The birth of Spam, a wartime staple. Before we step into the humming world of stainless steel machines and conveyor belts, let's rewind to a simpler but more desperate time. The year is 1937. The Great Depression has just eased and the world is inching toward a second global conflict. In the midst of economic uncertainty, Hormel Foods, a Minnesota-based company, launches a curious product, a canned, shelf-stable meat called Spam. The name? A blend of spiced ham, though some say it stands for shoulder of pork and ham. Others believe it means specially processed American meat. Regardless of the origin, Spam was designed with one mission: to provide affordable, long-lasting protein, especially for households without refrigeration. But Spam's big break came not at the supermarket, but on the battlefield. During World War II, refrigeration was scarce, especially on front lines and naval ships. Spam became a military staple, feeding millions of soldiers across Europe and the Pacific. Hormel reportedly shipped over 100 million pounds of Spam to Allied troops during the war. It was portable, it didn't spoil, and most importantly, it could be eaten cold, straight from the can. Troops returned home with mixed feelings about it, but Spam had already earned a place in American history. Over time, it spread across the globe, becoming a beloved part of food culture in countries like Hawaii, South Korea, Guam, and the Philippines. Fast forward to today, and Spam isn't just surviving, it's thriving. More than 8 billion cans have been sold worldwide, and new flavors like jalapeno, turkey, and bacon keep the product fresh and relevant. But beyond the nostalgia and wartime stories, there's a modern marvel behind each can, a combination of engineering, food science, and sheer efficiency. So how exactly does this humble meat go from pork cuts to pantry staple? Let's find out. Our journey begins in the early morning hours before the sun rises. Semi-trucks pull up to the receiving docks of the Spam production facility. Inside these temperature-controlled trailers are thousands of pounds of fresh pork and ham, sourced from regional farms. Unlike other processed meats, Spam doesn't rely on scraps or filler. It uses high-quality pork shoulder and premium ham cuts. The real deal. Workers in sanitized uniforms and hairnets unload the meat into chilled holding areas where strict food safety protocols kick in. Every cut is visually inspected and checked for temperature, texture, and color to ensure it meets Hormel's standards. Specially trained quality control teams use handheld scanners and thermal probes to verify that nothing has spoiled during transport. If anything is even slightly off, it's rejected. The approved cuts are then trimmed of excess fat and sinew by skilled workers using automated knives and trimming stations. This step ensures a uniform texture in the final product and helps the seasoning bind evenly later in the process. From here, the meat is moved, via conveyor or forklift, into large stainless steel storage bins, where it awaits the next phase, grinding. These bins can hold several hundred pounds of pork, each batch labeled and logged into a tracking system that follows it through the entire production line. Traceability is key. Every can of Spam can be traced back to its original batch of meat. Once the meat reaches the grinding area, the transformation begins. Massive industrial grinders, fitted with sharp rotating blades, begin breaking the pork and ham into a fine, uniform mince. The process is loud, mechanical, and incredibly efficient, designed to handle tons of meat per hour. After this initial grind, the meat is ready for its signature seasoning blend. And while the exact recipe is a closely guarded secret, we do know some of the key components. Salt, for flavor and preservation. Sugar, to balance the savoriness. Sodium nitrite, which gives Spam its iconic pink hue and helps prevent bacterial growth. Water, to aid in blending. And potato starch, which locks in moisture and gives Spam its familiar, slightly firm texture. These ingredients are fed into enormous rotating mixers. Think industrial-sized stand mixers, where the ground meat and spices are kneaded together into a thick, sticky paste. The sight is mesmerizing. The mixture gradually transforms from a loose grind into a smooth, elastic mass, uniform in color and texture and ready for canning. Each mixer is timed down to the second, Too short, and the blend won't be consistent. Too long, and the proteins might break down too much, affecting the final product. Technicians monitor every batch using digital control panels, ensuring precise blending temperatures, mixing speeds, and ingredient ratios. In this phase, there's no room for improvisation. Consistency is everything. Spam is made with just 6 main ingredients. That's fewer than most supermarket lunch meats or deli slices. Despite rumors, it contains no mystery meat, no weird byproducts, and nothing artificial beyond basic preservatives. It's simple, it's consistent, and it's been that way for over 80 years. Once perfectly blended, the meat mixture is piped through sanitary stainless steel tubes into the canning area, a place where human hands rarely touch the product. A fully automated can filling machine waits at the end of the line, capable of producing over 9,000 cans per hour. The machine fills each can with exactly 12 ounces of the meat blend, leaving just enough space at the top to accommodate the vacuum seal. Sensors check the fill levels in real time. If even one can is underfilled, it's immediately rejected and recycled back into the process. The pace is relentless, up to 165 cans per minute, but the precision is stunning. Each can receives an identical portion, delivered with almost surgical accuracy. It's clean, it's fast, it's efficient, and it's all leading up to a small but vital next step: vacuum sealing. With the filling complete, each can passes through a vacuum chamber. This step is critical. Air is the enemy of shelf life. Removing it helps prevent spoilage and bacterial growth. Once the air is sucked out, a metal lid is dropped onto the top and mechanically crimped down with several tons of pressure, creating an airtight seal. Now, the transformation from raw to ready begins. The sealed cans are stacked into large stainless steel carts and wheeled into towering industrial retort machines, essentially giant pressure cookers. Inside, the cans are subjected to extreme heat, over 240 degrees Fahrenheit, 115 degrees Celsius, for up to 3 hours. This step sterilizes the contents and cooks the meat directly inside the can, locking in the flavor, texture, and shelf stability. Each retort chamber holds thousands of cans at once. Temperature and pressure are constantly monitored by computer systems to ensure even cooking throughout the batch. Once the timer hits 0, the cans are slowly cooled, depressurized, and prepared for the next stage. The result? A fully cooked, bacteria-free product that can last for years without refrigeration, still retaining that signature taste and texture. Like what you're seeing? Want to uncover more food industry secrets and factory processes from around the world? Tap that like button, hit subscribe, and turn on notifications so you don't miss our next deep dive into the world of mass production. Now, back to the canning line. After cooking, the cans are extremely hot. They're placed on long conveyor belts to cool down naturally using ambient air and fan systems. Some factories use chilled water showers to speed up the process. Once cool, the cans pass under high-speed labelers. Each label is wrapped perfectly around the tin, with a code that shows where, when, and which batch it belongs to. These codes help track the product from production to the supermarket shelf. Now fully labeled and cooled, the cans are packed into boxes, usually 12 per carton. Automated arms handle most of the heavy lifting. These boxes are shrink-wrapped, palletized, and loaded onto distribution trucks. From this point, Spam is ready to travel across the globe, from U.S. grocery stores to military bases to beloved Hawaiian recipes. Did you know? In Hawaii, Spam is considered a cultural icon. People enjoy it with rice and seaweed as spam musubi, a local favorite. It's also big in South Korea, Guam, and the Philippines. Some countries even release limited edition flavors like garlic, teriyaki, and even hot and spicy. What started as war rations is now beloved comfort food in many corners of the world. The Spam factory is a marvel of automation and hygiene. Workers wear full-body uniforms, gloves, and hairnets. Sanitation is strict. Machines are regularly cleaned, and every shift begins with rigorous inspections. Even the air is filtered to prevent contamination. Temperature, humidity, and cleanliness are all digitally monitored 24/7. The result? A product that's not only shelf-stable but made under some of the highest food safety standards globally. Modern Spam production is also becoming greener. Many factories recycle steam and water, reduce packaging waste, and use biodegradable materials for shipping. Meat trimmings that don't make it into Spam are often used in other food products, ensuring minimal waste across the board. Each can of Spam is a tiny feat of engineering, chemistry, and history. It's not just canned meat, it's an icon of convenience, a symbol of survival, and a reminder of how technology can shape the food we eat. Have you ever tried Spam? What's your favorite way to eat it? Fried? Grilled? Right out of the can? Stay with us as we unveil the fascinating process behind every can of condensed milk. Raw milk collection. Our journey starts at dairy farms where fresh milk is collected from thousands of cows. Before it even reaches the factory, this milk undergoes strict quality checks to ensure it's free from contaminants and has the perfect fat content. Transported in temperature-controlled tankers, the milk arrives at the processing plant, where it's immediately chilled to maintain freshness. Inside the facility, the milk goes through a filtration process to remove any impurities. Once filtered, it's stored in large stainless steel tanks, where it awaits the next stage of production. Standardization and pasteurization. Milk consistency varies based on fat content, so to maintain uniformity, it undergoes a process called standardization. This ensures that each batch has the same composition, providing a consistent taste and texture. Next, the milk is pasteurized, heated to around 85 to 90 degrees Celsius, 185 to 194 degrees Fahrenheit. For a short period, this step eliminates harmful bacteria while preserving the milk's natural flavor. Unlike regular milk, condensed milk requires extended heat treatment to prevent spoilage and extend its shelf life. Evaporation. Here's where the transformation truly begins. The milk is transferred to giant vacuum evaporators where nearly 60% of its water content is removed. This step thickens the milk while intensifying its natural sweetness. The use of a vacuum lowers the boiling point, preventing the milk from scorching while preserving its rich, creamy texture. As steam rises from the evaporators, what remains is a concentrated, velvety liquid that is much denser than regular milk. But we're not done yet. There's one key ingredient missing: sweetening. Unlike evaporated milk, which remains unsweetened, condensed milk gets its signature taste from the addition of sugar. Large quantities of high-quality cane sugar are blended into the thickened milk, not only enhancing its flavor but also acting as a natural preservative. This sugar prevents bacterial growth, allowing condensed milk to have a much longer shelf life without refrigeration. The mixture is continuously stirred to ensure even distribution, giving it that silky smooth consistency we recognize in every spoonful. Cooling and homogenization. To prevent sugar crystallization, the sweetened milk is rapidly cooled and homogenized. Homogenization breaks down fat molecules, ensuring the milk remains creamy and doesn't separate over time. This step guarantees that every batch meets the highest quality standards before moving to the final stage. Packaging. If you're enjoying this inside look at food production, don't forget to like this video and subscribe for more amazing factory tours. Quality checks. Before being packed, the condensed milk undergoes rigorous quality control tests. Technicians check for consistency, texture, and sweetness, making sure it meets the company's exacting standards. Samples are also tested in labs for safety and shelf stability. Only after passing all inspections is the condensed milk ready for packaging. Packaging? Condensed milk is filled into sterilized cans, tubes, or Tetra Paks, depending on its intended use. These containers are sealed airtight, ensuring freshness and preventing contamination. Each can is labeled, coded, and checked for defects before being sent off for distribution. The final step? Shipping. Packed into cartons and loaded onto trucks, these sweet cans of goodness make their way to grocery stores, bakeries, and homes worldwide, ready to be transformed into delicious treats. And there you have it. From fresh dairy farms to high-tech factories, the journey of condensed milk is nothing short of amazing. The next time you add a spoonful to your coffee or drizzle it over your favorite dessert, you'll know the science and craftsmanship behind every drop. It all began in 1886 when Atlanta-based pharmacist John Stith Pemberton created a unique caramel-colored syrup, initially sold in local drugstores as a medicinal tonic. Mixed with carbonated water, it was originally marketed as a remedy for headaches and fatigue. Little did he know that his creation would become one of the most recognized brands on the planet. By the early 1900s, businessman Asa Candler acquired the formula and rapidly expanded the brand. Coca-Cola's iconic contoured bottle was introduced in 1915, ensuring that consumers could recognize the drink even in the dark. Over the decades, Coca-Cola has expanded its product lineup, introduced innovative marketing campaigns, and built a massive network of bottling plants worldwide. With its signature red and white branding, Coca-Cola has become synonymous with refreshment, nostalgia, and global culture. Today, Coca-Cola is more than just a beverage. It's a symbol of American culture and a dominant force in the soft drink industry. Available in over 200 countries and recognized by 94% of the world's population. One of the biggest mysteries surrounding Coca-Cola is its secret formula. Locked away in a high-security vault at the Coca-Cola headquarters in Atlanta, the exact recipe is known only to a handful of people. While the main ingredients include carbonated water, sugar, caramel color, phosphoric acid, natural flavors, and caffeine, the precise blend of these components remains one of the most well-guarded secrets in the food industry. Some believe that Coca-Cola's formula contains a unique blend of spices and citrus oils that give the beverage its distinctive taste. Over the years, rumors have spread about the use of exotic ingredients, with some even speculating about a mysterious ingredient known as Merchandise 7X. While Coca-Cola denies any drastic changes to the formula, some variations exist depending on local ingredient sourcing and regional preferences. The secrecy surrounding the formula has fueled speculation and intrigue for over a century. Stories have emerged about how the company ensures that no single person knows the entire recipe. Instead, different individuals only know partial elements, preventing the formula from being leaked or replicated. This level of secrecy adds to Coca-Cola's mystique, making it one of the most protected trade secrets in the world. The foundation of every bottle of Coke is water, and to ensure consistency across the globe, Coca-Cola employs an advanced multi-step water purification process. Water passes through filtration, reverse osmosis, and UV light treatment to eliminate any impurities before being used in production. This ensures that whether you're drinking Coca-Cola in New York, London, or Tokyo, the taste remains identical. The purification process is so rigorous that Coca-Cola's water quality often exceeds that of municipal drinking water. The company ensures that every bottle starts with a neutral and clean water base before moving to the next step. This guarantees that the flavor remains consistent worldwide, regardless of the local water supply. Once purified, the water is blended with sweeteners. Depending on the region, Coca-Cola is sweetened with either high-fructose corn syrup or cane sugar. Large tanks mix these sweeteners to create a base syrup, which is later infused with the signature Coca-Cola concentrate. Interestingly, in some countries like Mexico, Coca-Cola is still made with pure cane sugar, which many people claim gives it a different and more authentic taste. This variation has led to the popularity of Mexican Coke in other parts of the world, often sold at a premium price. Some dedicated fans even conduct taste tests to compare different versions, fueling ongoing debates about which formulation is superior. Now comes the most fascinating part, the legendary Coca-Cola syrup. This top-secret mixture is produced in a secured area of the factory, with only a select few workers having access. The syrup is carefully blended with the purified water and sweeteners before being transported to the carbonation phase. This syrup concentrate is actually produced in select locations worldwide before being shipped to bottling plants, where it is diluted and carbonated on site. This global approach ensures that every bottle of Coca-Cola maintains the same signature taste, regardless of where it is produced. The syrup is transported in special containers under strict security measures, ensuring that the formula remains protected at all times. If you're fascinated by the incredible technology and precision behind Coca-Cola production, don't forget to hit that like button. And if you love learning about how your favorite products are made, make sure to subscribe for more behind-the-scenes factory tours. Ever wondered what gives Coke its signature fizz? Carbon dioxide is injected into the mixture under high pressure, creating that refreshing burst of bubbles with every sip. The carbonation process is meticulously controlled to ensure every bottle or can has just the right amount of effervescence. If you've ever opened a bottle of Coke and heard that satisfying hiss, you've just experienced the power of precise carbonation. Carbonation does more than just add fizz. It enhances the overall taste experience. The bubbles create a tingling sensation that stimulates the taste buds, making Coca-Cola even more refreshing. The level of carbonation is carefully adjusted depending on the container type, ensuring the perfect balance between fizziness and smoothness. Now that the Coca-Cola mixture is ready, it's time for bottling. The factory uses a highly automated system capable of filling thousands of bottles and cans per minute. Plastic bottles start as small preforms, which are heated and blown into shape. Meanwhile, glass bottles and aluminum cans are sterilized and prepared for filling. As the bottles rush down the production line, high-speed filling machines precisely measure and dispense the Coca-Cola mixture, ensuring each container gets the exact right amount. Once filled, bottles are sealed with caps, while cans receive airtight lids. Labels and expiration dates are printed before the products move to quality control. At this stage, every bottle and can undergoes strict quality control to maintain Coca-Cola's reputation for consistency and safety. Advanced sensors and high-speed cameras meticulously inspect each container for leaks, incorrect fill levels, dents, or any imperfections that could compromise quality. These inspections happen in real time, with the technology capable of detecting even the slightest anomaly. Any defective products are immediately removed from the production line to ensure that only flawless items move forward. But the process doesn't stop there. Before leaving the factory, random samples from each batch are taken to dedicated laboratories where they undergo rigorous testing. This includes taste tests conducted by trained professionals to ensure the flavor profile matches Coca-Cola's iconic taste. Additionally, scientists analyze the chemical composition to verify that it meets the company's strict standards for quality, purity, and freshness. Beyond sensory evaluations, laboratory tests also assess carbonation levels, pH balance, and ingredient ratios to guarantee uniformity in every bottle and can. Even the packaging material is tested for durability to withstand shipping and handling. Only after passing these comprehensive quality checks are the products deemed fit for distribution. Once quality control is complete, the bottles and cans move on to the packaging stage. They are labeled with precise details, including the production date and batch number, to ensure traceability. Sophisticated robotic arms efficiently place the labeled containers into cases, stacking them with remarkable accuracy and speed. These cases are then wrapped and secured on pallets, making them ready for shipping. From massive distribution centers strategically located worldwide, Coca-Cola products are transported via an extensive logistics network. This involves trucks, ships, planes, and even specialized refrigerated containers to maintain freshness during transit. Whether heading to bustling city supermarkets, rural convenience stores, or vending machines in remote areas, the journey is carefully coordinated to minimize delays and maintain product integrity. Coca-Cola's distribution network is a marvel in itself, operating around the clock to ensure that a cold can of Coke is always within reach, no matter where you are in the world. Beyond production, Coca-Cola is continuously innovating its packaging and sustainability efforts. In recent years, the company has invested in eco-friendly initiatives, such as developing 100% recycled PET plastic bottles and reducing water consumption in factories. Their World Without Waste initiative aims to collect and recycle one bottle or can for everyone sold by 2030. Additionally, Coca-Cola has been experimenting with biodegradable packaging and investing in renewable energy sources to reduce its carbon footprint. These sustainability efforts reflect the company's commitment to a greener future, while still delivering the same refreshing beverage loved by millions. At the heart of every can is a carefully measured combination of caffeine, taurine, B vitamins, and alpine spring water, a formula that has remained unchanged for decades. The process starts with purified water sourced from alpine springs, ensuring maximum quality and consistency. This water is pumped into massive stainless steel mixing tanks, where it is blended with an exact amount of sugar or sweeteners, depending on whether it's the original or sugar-free variant. To create the drink's energizing effects, synthetic caffeine and taurine are added next. The caffeine provides that familiar mental boost, while taurine, an amino acid found naturally in the human body, supports neurological function. The mix is then fortified with B-group vitamins, which help convert food into energy. After thorough blending, the liquid undergoes a filtration process to remove any impurities and ensure consistency. The mixture is then carbonated, giving Red Bull its signature fizz. Carbon dioxide is injected into the blend under precise conditions, creating that refreshing, lightly sparkling effect that fans love. At this stage, the drink is cooled and transferred to massive holding tanks, ready for canning. Red Bull's sleek aluminum cans arrive at the factory in bulk, stacked in towering pallets. Before filling, each can is thoroughly washed and sterilized to maintain the highest hygiene standards. Then, in an ultra-fast and precise filling line, each can is filled with the carbonated Red Bull mixture in a matter of milliseconds. If you're enjoying this behind-the-scenes look, don't forget to like this video and subscribe for more fascinating factory tours. Once filled, the cans move along a conveyor to be sealed with precision-engineered aluminum lids. This step is crucial in maintaining Red Bull's shelf life and signature taste. The lids are crimped onto the cans using high-speed sealing machines, ensuring an airtight seal. Next comes the branding process. Each sealed can passes through a labeling station where the instantly recognizable blue and silver design is printed onto the surface. This step happens at an astonishing rate, with thousands of cans processed per minute. Now it's time for quality control. Every single Red Bull can is checked for imperfections, ensuring it meets the brand's strict global standards. Cans are weighed, pressure tested, and visually inspected to ensure they are filled correctly and free of defects. But production doesn't stop at just making the drink. Red Bull factories are built with sustainability in mind. The company has taken significant steps to reduce its carbon footprint by using energy-efficient machinery, optimizing water usage, and implementing eco-friendly packaging methods. In fact, Red Bull's aluminum cans are 100% recyclable, and the brand continuously works to improve its environmental impact. Once quality control is complete, the cans are grouped into multi-packs or loaded into larger cases for shipment. The fully packaged Red Bull cans are stacked onto pallets, shrink-wrapped for stability, and transported via conveyor belts to warehouse storage areas. From here, they are loaded onto trucks and distributed to retailers worldwide, ensuring Red Bull remains available in over 170 countries. Red Bull's distribution network is a well-oiled machine. Warehouses across the globe keep inventory moving swiftly, ensuring shelves are always stocked. From vending machines in Tokyo to convenience stores in New York, every can of Red Bull follows a meticulously planned route from factory to consumer. Beyond production, Red Bull's influence extends far beyond just being a beverage. The company has built an empire around extreme sports, sponsoring high-adrenaline events in motocross, Formula One racing, snowboarding, and even space jumps. This marketing strategy has made Red Bull synonymous with adventure, pushing the limits of human endurance and innovation. But what makes Red Bull stand out is not just the drink itself, but its precision-engineered production process. The brand operates multiple production plants worldwide, each fine-tuned to produce millions of cans per day. Cutting-edge robotics ensure that every step, from ingredient blending to packaging, runs seamlessly. Advanced AI-driven quality control systems continuously monitor production, instantly flagging any anomalies and maintaining the brand's commitment to excellence. Even the logistics of Red Bull's supply chain are meticulously designed. The company employs a just-in-time manufacturing approach, ensuring minimal waste and maximum efficiency. From the moment raw materials arrive at the factory to the second a can lands in a store, every phase is optimized for speed and sustainability. And then there's Red Bull's marketing, a powerhouse in its own right. The company doesn't just sell an energy drink, it sells a lifestyle. Red Bull Media House produces high-octane content featuring world-class athletes, breathtaking stunts, and record-breaking feats. Whether it's sponsoring extreme sports events or creating viral video campaigns, Red Bull has mastered the art of brand storytelling, ensuring that every sip of the drink is associated with thrill-seeking energy and limitless possibilities. It all starts with tiny tobacco seeds, which are so small that thousands fit into a single gram. These seeds are sown in controlled environments, usually greenhouses, where they are nurtured and carefully monitored. Once the seedlings reach a sufficient size, they are transplanted into open fields, where they are given ample space to grow. Farmers ensure that the plants receive the optimal amount of sunlight and water, while also protecting them from pests and diseases. This stage is labor-intensive, as the plants require constant attention to maintain their health and quality. Regular weeding, fertilization, and soil management are essential to encourage robust growth. After about 4 to 6 months, the plants mature, their large, vibrant leaves beginning to show hints of yellow. This color change signals that the leaves are reaching the ideal stage for harvest. Timing is crucial. The leaves must be neither too green nor too dry. Experienced farmers can gauge the perfect moment just by the texture and color of the leaves. Harvesting is a precise process. In some regions, skilled workers carefully hand-pick the leaves to avoid damaging them, while in larger operations, automated cutting machines are used to speed up the process. Only the highest quality leaves are selected, as they will directly impact the final product's flavor and smoothness. The harvested leaves are bundled and transported to curing facilities, where they are prepared for the next stage of production, curing and fermentation. Freshly harvested tobacco leaves are far from ready for cigarette production. To unlock their characteristic flavor and aroma, they must undergo a crucial process known as curing. This involves drying the leaves under controlled conditions to remove excess moisture while preserving the natural oils and compounds that contribute to their taste. There are several curing methods, each chosen based on the type of tobacco and the desired flavor profile. Air curing. The leaves are hung in ventilated barns and allowed to dry naturally over several weeks. This method produces a light, mellow flavor, often used in pipe and chewing tobacco. Flue curing. One of the most popular methods for cigarette tobacco, where warm air circulates through curing barns, gradually drying the leaves over 7 to 10 days. This results in a bright, mild tobacco flavor, commonly associated with cigarettes. Sun curing. The leaves are spread out under direct sunlight, where they dry quickly, developing a sweeter, milder taste. This technique is common in Mediterranean regions. Fire curing. Wood fires are set in barns to generate smoke, which infuses the tobacco with a rich, smoky flavor. This method is often used for stronger, more robust tobacco blends. Once cured, the tobacco enters the fermentation phase, a slow aging process that refines its taste, removes harshness, and enhances smoothness. During fermentation, the leaves are carefully stacked and covered, allowing natural enzymes to break down undesirable compounds. This aging process can take several months and is crucial for developing the rich, complex flavors associated with premium cigarettes. Processing the tobacco. At the factory, large bundles of cured tobacco arrive for further processing. The first step is sorting, where skilled workers and automated systems categorize the leaves based on quality, size, and color. This sorting ensures that only the finest leaves are reserved for premium blends, while lower-grade leaves may be used for budget brands or flavored cigarettes. Next, the leaves undergo conditioning, where they are moistened and gently heated to make them pliable for further processing. This step is crucial, as overly dry leaves can crumble during the next stage. Stripping. Stripping involves removing the central veins from the leaves, as these tough, fibrous parts can negatively affect the smoking experience. The stripped tobacco is then shredded into fine, even strips, ensuring consistency throughout the blend. Cigarette manufacturers carefully mix different types of tobacco to create unique flavor profiles, maintaining a consistent taste across every batch. Flavoring agents and additives may also be incorporated at this stage to enhance aroma or smoothness. Rolling and cutting. With the tobacco prepared, it's time to roll and cut the cigarettes. The shredded tobacco moves to high-speed rolling machines that can produce up to 20,000 cigarettes per minute. The process is an impressive display of precision and efficiency. A continuous sheet of thin cigarette paper rolls out, forming a long, unbroken tube. A precise amount of shredded tobacco is evenly distributed along the paper, ensuring uniform filling. The paper is tightly rolled around the tobacco, creating a long, cylindrical rod. The rod is cut into individual cigarette lengths, each stick uniform in size and density. Throughout this process, automated sensors monitor every step, detecting any inconsistencies in filling or rolling. Defective cigarettes are immediately removed from the line to maintain quality standards. Adding the filter. The next step involves attaching filters to the freshly rolled cigarettes. Filters are made from cellulose acetate, a fibrous plastic material designed to reduce the harshness of smoke. The filters are cut to length and wrapped in tipping paper, which often includes ventilation holes for a smoother draw. The filter tips are then securely bonded to the cigarette rods using a special adhesive. Advanced machines ensure that the alignment and attachment are flawless, as any irregularity can affect the smoking experience. Once assembled, the finished cigarettes undergo rigorous quality control. Automated scanners check for size accuracy, proper tobacco filling, and any visual defects. Cigarettes that don't meet the strict criteria are discarded. Packaging and distribution. Once quality control is complete, the cigarettes are bundled into packs of 20, which are then wrapped in foil to preserve freshness and sealed in branded cardboard packaging. An additional layer of cellophane is applied to protect against moisture. The packs are arranged into cartons, which are then stacked onto pallets for shipping. Massive logistics operations coordinate the movement of these products from factories to distribution centers worldwide. Whether transported by truck, ship, or plane, every shipment is carefully tracked to ensure it reaches retail outlets promptly. Through an efficient distribution network, cigarette manufacturers ensure that their products are always available on store shelves in vending machines, and at various points of sale across the globe. If you're amazed by the engineering and precision behind cigarette production, hit that like button. Want to see more behind-the-scenes factory tours? Subscribe to our channel so you never miss out on the next deep dive into the world of manufacturing. Sustainability and innovation. Despite the declining number of smokers in many countries, cigarette manufacturers continue to adapt by implementing new technologies. Some companies are developing biodegradable filters to reduce pollution, while others invest in alternative nicotine products like heated tobacco and e-cigarettes. Efforts are also being made to reduce the environmental impact of cigarette production. Many factories have switched to renewable energy sources, optimized water usage, and adopted recycling programs to manage waste more efficiently.
The journey of an EV battery begins deep within the earth, where essential raw materials like lithium, cobalt, nickel, and graphite are extracted. These materials are the lifeblood of EV batteries, with lithium taking center stage as the key ingredient in lithium-ion batteries. But where do these crucial elements come from? Lithium. Lithium is primarily extracted from two sources: salt flats and hard rock mines. In places like South America's Lithium Triangle, spanning Argentina, Bolivia, and Chile, the extraction process involves pumping lithium-rich brine water from underground reservoirs to the surface. This brine is spread across massive evaporation ponds, where the sun does the work of slowly evaporating the water, leaving behind concentrated lithium salts. This process can take anywhere from 12 to 18 months to complete. Nickel, cobalt, and manganese. These metals are typically mined from underground deposits found in places like the Democratic Republic of Congo for cobalt, Russia, Indonesia, and Canada. Miners extract large quantities of ore, which is then crushed and processed to separate and purify the metals. Nickel is particularly valuable for EV batteries because it boosts energy density, allowing cars to travel longer distances on a single charge. Once the raw materials are extracted, they undergo rigorous purification processes. This step is critical since even trace amounts of impurities can degrade the battery's performance, reduce its lifespan, or increase the risk of malfunction. The purified materials are then shipped to specialized processing plants, ready for the next crucial stage: cathode and anode production. Step 2. Cathode and anode production. At the heart of every EV battery lies the cathode and anode, the two main electrodes that store and release electrical energy. Think of them as the positive and negative terminals of a battery. Cathode production. The cathode is crafted from a precisely engineered mixture of lithium, cobalt, nickel, and manganese. These materials are blended into a fine powder and then mixed with a special binder. The resulting slurry is coated onto aluminum foil, which serves as the conductor for the electric charge. Anode production. The anode, on the other hand, is primarily made of graphite. Similar to the cathode process, the graphite powder is mixed with a binder and coated onto a thin sheet of copper foil. Graphite's structure allows it to store lithium ions during charging, making it a vital component in battery performance. Once coated, both cathode and anode foils are dried, pressed, and cut into precise shapes. These sheets will later be layered together to form the battery's core. Any imperfections in this process, such as uneven coating or air bubbles, can compromise the battery's stability and efficiency. This step requires precision on a microscopic level. Step 3. Cell assembly. With the cathode and anode materials ready, it's time for the most complex and exciting stage: assembling the battery cells. This process is often compared to building a high-tech sandwich, with each layer playing a crucial role. First, a porous separator, made from a thin, flexible membrane, is inserted between the cathode and anode to prevent them from touching. This separator allows lithium ions to flow between the two sides while preventing short circuits. The sandwich is then either wound into a spiral, for cylindrical cells, or stacked flat, for prismatic and pouch cells. Cylindrical cells resemble a tightly wound jelly roll, while pouch and prismatic cells are arranged like flat stacks. This structural difference influences how the cells are used in EV battery packs. Once the assembly is complete, the cells are encased in protective shells. Cylindrical cells are placed in metal canisters, while pouch cells are sealed in flexible, vacuum-sealed pouches. These airtight seals are crucial for keeping moisture and oxygen out, as even a small amount of contamination can affect battery performance and longevity. Step 4. Electrolyte filling. At this stage, the battery cells are still dry and cannot conduct electricity. To activate them, manufacturers inject an electrolyte, a special liquid or gel, into each cell. The electrolyte acts as the bridge that allows lithium ions to move between the anode and cathode during charging and discharging. This process is conducted in a highly controlled, moisture-free environment to prevent contamination. The cells are then soaked to ensure the electrolyte is fully absorbed into the separator, anode, and cathode materials. After soaking, the the cells are sealed again to create an airtight environment, ensuring no moisture or oxygen enters. The cells are left to age for a period, allowing the electrolyte to fully integrate with the other components and stabilize the battery's chemical structure. Step 5. Formation and aging. Now it's time to wake up the battery. Unlike flipping a switch, activating a battery is a slow, deliberate process known as formation. During formation, each cell is charged and discharged several times to trigger and stabilize the chemical reactions inside. This process establishes the battery's final capacity, stability, and lifespan. If any cell fails to meet performance standards, it's either reworked or discarded. This step can take several weeks to complete. While aging, each cell is closely monitored. Advanced AI-driven testing systems scan for voltage fluctuations, temperature changes, and capacity issues. Any defective cells are identified and removed to ensure only the highest quality cells continue to the next stage. If you're enjoying the video, then kindly like, share, and subscribe to our channel. Step 6. Battery pack assembly. While individual battery cells are powerful on their own, they're not enough to power an electric vehicle. So, manufacturers combine hundreds, sometimes thousands of these cells to create a battery pack. The cells are placed into specially designed modules. These modules are like mini batteries that are grouped together and connected with high-voltage wiring, sensors, and cooling systems. Cooling is essential to prevent the pack from overheating during use. Each module is tested, and once verified, they're connected together to create the full battery pack. The pack is then placed inside a strong metal or composite casing to protect it from impacts, debris, and extreme weather. This protective shell is crucial for safety, as the pack is often placed beneath the vehicle's floor. Step 7. Quality control and testing. Before an EV battery leaves the factory, it's subjected to an extensive series of quality control tests. Each battery's voltage, capacity, and internal structure are examined. Advanced X-ray machines, ultrasonic scanners, and thermal imaging are used to detect microscopic flaws that could compromise the battery's integrity. The battery pack is also exposed to extreme conditions, such as heat, cold, and vibration, to simulate the harsh environments it will face in an EV. If a battery fails any of these tests, it's either scrapped or sent for rework. Step 8. Final integration into EVs. The final step is to install the battery pack into the electric vehicle. The pack is lifted into the vehicle's chassis and securely bolted into place. Sensors and control units are connected to ensure the battery's health can be monitored in real time. Once installed, the entire vehicle is tested to ensure the battery system works perfectly. Charging, discharging, and energy efficiency are all verified before the EV rolls off the production line and into your driveway. The journey of a battery. From the depths of the earth to the assembly line of a state-of-the-art factory, the process of making an EV battery is one of the most complex manufacturing feats in the world. Each step, from mining raw materials to charging the first cell, is part of a larger mission to create cleaner, more efficient transportation for our future. Designing and modeling. Before any steel is cut or machinery is built, it all starts on paper, or more accurately, on powerful 3D modeling software. Architects, engineers, and designers work together to create a vision for the ship. This includes every detail, from the structural layout to the placement of swimming pools, theaters, and cabins. The blueprints aren't just for aesthetics. They also ensure the ship meets strict safety regulations. Each deck is analyzed to accommodate weight distribution, stability in rough seas, and emergency evacuation protocols. Designing a cruise ship is a balancing act, blending function and luxury with the ship's primary purpose, to provide an unforgettable experience for passengers. Did you know some of the world's largest cruise ships have more than 20 decks, over 2,000 cabins, and can accommodate up to 8,000 people, including passengers and crew? That's a small city on the water. Step 2. Cutting and shaping the steel. Once the design is finalized, it's time to bring the ship to life. The process begins in the steel yard. Giant sheets of steel, each weighing several tons, are delivered to the shipyard. These are the building blocks of the ship, forming its frame and hull. Advanced laser and plasma cutting machines are used to slice through the steel with incredible precision. These machines can work for hours, cutting sheets into complex shapes and sizes needed for the ship's structure. But it's not just about cutting. The steel must also be shaped and bent into curves that match the ship's hull design. Specialized machines and hydraulic presses are used to bend the steel into the exact contours required. This is no small feat, considering the sheer size and thickness of the materials involved. Every piece of steel is inspected multiple times to ensure it meets quality standards. Even the smallest imperfection could cause issues later. Step 3. Assembling the blocks. Here's where the magic of modern shipbuilding comes in. Instead of building the ship from the ground up, it's constructed in sections known as blocks. Each block is essentially a fully functional module, complete with pre-installed piping, wiring, and ventilation systems. Think of it like assembling a giant Lego set, but each brick weighs hundreds of tons. These blocks can range from small sections to entire segments of the hull, complete with multiple decks. The blocks are built in separate workshops, which allows different teams to work on multiple parts of the ship simultaneously. This parallel process speeds up construction significantly. Once the blocks are ready, they are transported to the assembly area using enormous cranes capable of lifting hundreds of tons in one go. Watching these cranes in action is like watching a scene from a sci-fi movie. Step 4. Keel laying, the ship's berth. The keel is the backbone of the ship, running from bow to stern. Once it's laid, it marks the official start of the ship's assembly. This is such an important milestone that it's often celebrated with a ceremony. A coin or token is placed under the keel for good luck, a tradition that dates back centuries. With the keel in place, the ship begins to take shape. Workers start welding the blocks together, creating the basic structure of the hull. This process takes months and involves thousands of skilled laborers and automated welding machines working around the clock. The welding sparks flying across the shipyard are a sight to behold, a dazzling reminder of the hard work and precision involved. Step 5. Completing the hull. As the blocks are joined, the ship begins to resemble the giant vessel it will soon become. The hull is the ship's outer shell, and it must be both incredibly strong and perfectly watertight. The hull is also painted with specialized marine coatings to protect it from the harsh ocean environment. These coatings prevent rust and discourage marine organisms like barnacles from attaching to the surface. It's a painstaking process, requiring thousands of gallons of paint to cover the massive structure. Step 6. Outfitting the interiors. Once the hull is complete, it's time to transform the steel structure into a luxury cruise ship. The outfitting stage is where the magic happens. Teams of workers install everything from staircases and chandeliers to water slides and wave pools. Cabins are outfitted with beds, furniture, and entertainment systems. Restaurants and theaters are constructed, each one uniquely themed to enhance the passenger experience. One fascinating part of this process is how modular the interiors are. Prefabricated cabin units are often built off-site, fully furnished, and then installed into the ship like puzzle pieces. This not only saves time, but also ensures a consistent level of quality. Step 7. Installing engines and propulsion. No ship can move without a heart, and for a cruise ship, that heart is its propulsion system. Most modern cruise ships use advanced azimuth thrusters, which allow the ship to move in any direction, even sideways. These thrusters are powered by massive engines that can generate tens of thousands of horsepower. The engines are designed to be as efficient and environmentally friendly as possible. Many newer ships use LNG, liquefied natural gas, which burns cleaner than traditional fuels. Some even incorporate hybrid systems with battery storage for reduced emissions. Step 8. The nerve center. The bridge is where the ship's operations are controlled. It's equipped with state-of-the-art navigation systems, radar, and communication equipment. The captain and crew rely on these tools to safely guide the ship through various weather conditions and tight ports. What's fascinating is how automated many of these systems are. Modern cruise ships can practically steer themselves using advanced autopilot systems, though the crew is always on hand to ensure everything runs smoothly. Step 9. Testing. Before the ship can welcome passengers, it must prove itself at sea. Sea trials are rigorous tests conducted in open water to evaluate the ship's performance, safety systems, and seaworthiness. During these trials, the ship is pushed to its limits. Engineers test the engines, steering systems, lifeboats, and even the ship's ability to handle emergency situations. It's the ultimate quality control check before the ship is handed over to its owners. Step 10. The finishing touches. After passing sea trials, the ship returns to the shipyard for final touches. This includes stocking the kitchens with food, filling the swimming pools, and training the crew. Every detail is checked and double-checked to ensure the ship is ready for its maiden voyage. The ship's name is revealed during a grand christening ceremony, often attended by dignitaries and celebrities. A bottle of champagne is smashed against the hull, a tradition believed to bring good luck. The journey begins, and just like that, the ship is ready to set sail. What began as sheets of steel and a dream has transformed into a floating city, ready to carry passengers to exotic destinations around the globe. Behind every grand staircase, every gourmet meal, and every sunset view is the hard work and dedication of thousands of people. Next time you see a cruise ship on the horizon, remember the incredible journey it took to get there, a testament to human ingenuity and teamwork. If you enjoyed this deep dive into shipbuilding, don't forget to like, subscribe, and hit that notification bell. We'll bring you more behind-the-scenes looks at how the world's most incredible machines are made.